Welcome students. Today we will be starting with another topic in dynamics, that is kinetics of particles 3. Now as it is kinetics, we know that we will be considering the forces responsible for the motion, and as it is particles, we will be not considering the dimensions of the body while solving the problems. In our previous lectures we have seen that kinetics of particles 1 was popularly known as Newton's second law, or it was known as D'Alembert's principle. Similarly, we have seen that kinetics of particles 2 was popularly known as work energy principle. Similarly, this kinetics of particles 3, this chapter which we are going to start today, is popularly known as impulse momentum. So before proceeding forward, let us understand these two terms. What do you mean by impulse and what do you mean by momentum? And also we will see that what is the relation between these two terms, that is impulse and momentum. So let us start with that. So let us start with the term impulse. And to understand it, let us consider a particle of mass, let us say m, and subjected to a force of F newtons for a time t seconds. This force F is said to impart an impulse on this particle of mass m, and the magnitude of this impulse is the product of the force applied and the duration for which it is applied on the particles. Hence I can say that the magnitude of the impulse is nothing but force multiplied by time. Now this relation impulse is equal to F into T. This holds true when the force is constant over a period of time. Now what happens if the force changes or the force goes on changing with respect to time? So in that case, impulse will be given as integration of f dt within the limits t1 to t2, wherein t1 is the starting time and t2 will be the ending time of the force applied. Now let us go through another term which is known as an impulsive force. A large force when acts for a very small amount of time and causes a considerable change in the particle momentum is called as impulsive force. So the three main things which you need to remember for impulsive force is: the first one is a very large force, the second word is this one, that is for very small time, and the third one is change in the particle momentum. For example, let us say this is a particle which is moving along this side, and this particle, let us say, is moving along this side. When these two particles collide with each other, they separate, and after separation the collision for these two particles will be for a very short period of time, that is t, but it will impart a large force on each other. So large force on each other, minimum time, and after collision this will change the velocities of this particle, that means it will change the momentum. Hence we can say that an impulsive force has been imparted on this particular body. Similarly, if you can observe in this particular image, you can see that there is a bullet which is fired from a gun. Again, a very large amount of force, that is a trigger force, is being applied for a very less amount of time. Hence we can say that it is an impulsive force. In this second figure, wherein there is a player who is hitting a ball, again here you can see when the ball and the bat are in contact at this particular position, the impact is very high and is also for a less amount of time, and also is changing the momentum of the ball. Hence we can say that it is a impulsive force. And same case is valid for this tennis game, wherein again the player plays a shot, the contact between the bat and the ball is for very less time, force is very high, and it changes the momentum of the body. Hence we can say that it is nothing but the impulsive force. So impulsive force, again I repeat, the three main things are: when a large force acts for a very small time and causes a change in particle momentum, then it will be known as the impulsive force. So this completes about the first part of this topic, that is impulse. Now let us understand about the second part, that is momentum. We all know from our basics that momentum is the product of mass and velocity. Now if I want the change in momentum, it will be final momentum minus initial momentum. Mass into velocity, because it is v, I will consider this as final momentum, and this will be nothing but my initial momentum. And if I take the subtraction of the two, I will get the value of change in momentum. So now we have seen what is impulse, and also we have seen what is momentum. Now, as we have seen in work energy principle, there was some relation between work and energy. So there should be, or there is some relation between impulse and momentum. So let us see what is that relation. So it is given that for a particle or a system of particles acted upon by a force during a time interval, the total impulse acting on the system is equal to difference between the final momentum and the initial momentum. That means I can say that impulse is nothing but the difference of final momentum and initial momentum. So if I convert this into a mathematical form, I can write impulse is equal to mv minus mu, where m into v is the final momentum and m into u is the initial momentum. If I just rearrange these terms, I will get impulse plus m into u is equal to m into v. Or I can say that the final momentum of a body is equal to initial momentum plus the impulse. In previous slide, we have seen the mathematical expression for impulse, which says that impulse is equal to t1 to t2 integration of f dt. So I am just substituting in place of impulse as integration t1 to t2 f dt plus mu is equal to mv. This becomes impulse momentum equation. In other words, I can also write it as ft plus mu is equal to mv. And this equation will hold true only when force is constant over a period of time, which we have also seen in the previous slide while discussing on the impulse part. So when the force changes with respect to time, the impulse will be integration of t1 to t2 f dt, and when force is constant with respect to time, I will write impulse is equal to f multiplied by t. So with this we have completed the theoretical aspects of the impulse momentum equation and what is impulse and what is momentum.